In Step 8, we discussed using optimization experiments to optimize the settings of our vital x's when they are continuous factors. In Step 9, we will discuss the principles of statistical tolerancing in implementing such changes. Click Next to continue. In this final step of the Improve phase, we will define the basic purpose of statistical tolerancing and define the basic principles of statistical tolerancing. Click Next and we'll get started. The basic purpose and concept which guide tolerancing are straightforward. The purpose is to establish the range of values for each vital x that will satisfy customer requirements. The concept is equally direct. If you know the relationship between x and y, and also the required specifications of y, then you can set the tolerance of the x factor. Click Next and we'll look at a simplified example. In the next few minutes, we will go through an exercise which will culminate in developing the tolerances for a specific task. We will begin by defining some basic terms, developing the transfer function, and then applying tolerancing techniques to develop a final description of the solution. The transfer function we're looking at involves the relationship between hours of exercise per week and pounds of weight lost per week. Given those two factors, which one do you think is the x and which one is the y? Select your response and click on Done to see if you're right. Very good! Weight loss is a function of exercise, so exercise is the x and weight loss is the y. We know there are more variables, but remember that this is a simplified example. Click Next to continue. So in Step 8, where we determine variable relationships, we would produce a chart like that shown here, in order to provide a visual representation which quantifies the relationship between weight loss and hours of exercise per week. In order to determine how much exercise we need to achieve a specific weekly weight loss, we draw a horizontal line from the desired weight loss to the transfer function line, and then drop a vertical line from that intersection to the exercise scale. We can then read the required exercise time directly from the scale. So this tells us that we need to exercise 2.2 hours per week in order to lose 2.5 pounds per week. This is a simple example, but we can add additional parameters which will more accurately reflect the real world. Click Next and we'll start doing just that. We have decided that we would like to lose at least 1 pound per week, and preferably 2. For health reasons, we would like to lose no more than 3 pounds per week. So how do we translate this to our statistical model? First, our target is 2 pounds per week. So we draw the horizontal line from that value to the transfer function, and then drop the vertical line down to the exercise scale where it intersects 2 hours per week. We then set our lower specification limit at 1 pound per week, which means we need to exercise at least 1.4 hours of exercise per week to meet the minimum goal. Finally, we set our upper specification limit at 3 pounds, which corresponds to exercising no more than 2.6 hours per week, or we may exceed our upper spec limit. So our preliminary statement is that we should exercise 2 hours per week with a tolerance of plus or minus 0.6 hours per week. Click Next to continue. Before we can finalize these limits, we need to take into account the variation of our measurement system. As it turns out, there is a 1/4 pound variation in our measurement system, so we need to modify our limits accordingly. First, we center a 1/4 pound range over the LSL and the USL at the pounds per week scale. We then use these variation ranges to adjust our lower specification limit upward to 1.5 hours of exercise and our upper specification limit down to 2.5 hours of exercise. So, accounting for any variation due to our measurement system, our new tolerance around 2 hours per week is plus or minus 0.5 hours of exercise. At this point, we look at the transfer function and can say that the part between the adjusted lower spec limit and the adjusted upper spec limit defines the acceptable range. Click Next to continue. In some cases, there may also be measurement variation in the x. In that case, you would use the same technique to adjust the lower and upper specification limits for the x values after they had been set and adjusted for y value measurement variation. The results, as you can see, are a further tightening of the tolerances for x. These adjustments will be critical in the next phase, control. This is a graphical representation and simplification of the statistical tolerancing process. A detailed look at this process and its calculations will be covered in further training. Click Next to continue. Let's summarize this step. Process tolerances are based upon specification flowdown from customer requirements. You will need to adjust tolerances due to variation in both the process and product measurement systems, unless those variations are small enough to ignore. This is a very simplified overview of statistical tolerancing. There are times when trying to determine the tolerancing for multiple variables becomes extremely complex. Consult with your master black belt for assistance with such situations. Click Next to continue. Congratulations! You have finished Step 9 and are ready for the phase quiz to complete the Improve phase. Before I return you to Siggy, I'd like to say it's been a pleasure working with you on this project. You're on the home stretch of this program, so I'll let you go on to the quiz so you can get into the final phase
really
of the
knows
DMAIC
his
process.
stuff, doesn't he?
Control.
Before we go on to the phase quiz, let's take a moment and review the 3 steps of the Improve phase. In Step 7, we screened the potential causes identified and analyzed in order to determine which were the true vital X's. In order to do this, we reviewed the applicability of a design of experiment strategy and designed and performed a full factorial screening DOE of the candidates to determine the true vital X's. We also determined our improvement strategy based upon the characteristics of the vital X's. Were they operating parameters or critical elements? Click Next to continue. We examined how optimizing experiments and regression could be used, when appropriate, to finalize our recommended solution. We also described the fractional factorial technique as a means of reducing the number of runs in an experiment, in order to meet considerations such as budgetary or schedule constraints. Click Next to continue. The final step in the Improve phase concerns statistical tolerancing. First, we defined the purpose of statistical tolerancing. Then, we defined the basic principles of statistical tolerancing. Finally, we applied statistical tolerancing to an example. Click Next to continue. Click Next to go on to the phase quiz. However, if you choose, you can go back and review the steps of Improve and come back to take it later. Okay, here's the first question. We've got a mini-tab printout on the screen. Take a close look at it and study all the factors, including the interactions. Determine which of the terms are the significant ones. Select your answer and click on Done to submit your response. Very good. You looked at the p-values and saw that only time, temp, and the time-temperature interaction had a p-value of less than 0.05, which is why they are significant factors. Click Next to continue. To do a full factorial DOE for 5 factors at 3 levels without replications, how many individual tests would be required? Select your choice among the 4 answers by clicking on it, and then clicking Done to submit. That's right. You take number of levels, which is 3, and raise it to the power of the number of variables, 5 in this case. That gives us 243. Click Next to continue. Place the 3 events in the correct order by dragging them to the boxes next to their appropriate steps in Improve. Click Done to submit your answer. Excellent! In Step 7, we screened the potential causes to identify the vital X's. In Step 8, you established the transfer function. And in Step 9, we established tolerances for our process. What best describes the reason you are doing a design of experiment? Select your answer and click on Done to submit. You're right. All answer choices are correct. Click Next to continue. In terms of the data entry task, which of the following items listed here is a potential lurking variable? Select the one best answer and click Done to submit. Very good. All three of the values listed are potential lurking variables. By randomizing the time and day of your experimental tests, you can help eliminate these kinds of lurking variables from biasing your results. Click Next to continue. Which of the tools can be used to help determine the transfer function between vital X's and the CTQs? Select all that apply. You're right. Regression analysis and design of experiments determine the transfer function. Well, you've finished the improve phase. Only one more to go before you hit the final knowledge check and completion. Take a look at your score. If you didn't get the majority of the questions correct, you may wish to review all or part of this phase before continuing on.